Hello student, let's try to understand isomerism in coordination compound. First of all, what do you mean by isomerism, student? So the coordination compounds which have same molecular formula but have different ligands attached to the central metal atom in different ways are called isomers. So isomers are having the same molecular formula, student, and that is the linking atom may be different, student. These isomers have different properties, student, and the phenomena that give rise to different isomers are called isomerism. Okay, the number of possible isomers increases with coordination number. We limit our discussions to the more common coordination number 4 and 6. So that is what the coordination number, they are having the same molecular formula but differ in the linking atom, that is differ in the ligands directly connected with the what, student? Coordination central metal atom. Here you see, student, two or more than molecule with the identical formula, that is called they are isomers. They are the two types of isomers are there, student. Okay, what are the, that is structural or the constitutional isomerism. First one is ionization, linkage, coordination and hydrated. Second one is the stereo isomerism, student, geometrical and optical. So let us try to understand the most important one, the structural isomerism, student. What do you mean by structural isomerism? This isomerism arises due to different in the structure of the complex coordination compound. This isomerism include following. So here the structures get different, student, that is what is called structural isomerism, student. The first one is the ionization isomerism. What do you mean by ionization isomerism? Compound with the same molecular formula but which give different ions in solution exhibit ionization isomerism. Now student, if you see this compound, this one, both are having the same molecular formula, student, but if dissolve in water it will give bromine ion and it will give Cl ion. Similarly, if you see the second one, student, same molecular formula is there, but what is there, it will give sulfate ion and it will give bromine ion. So it is violet color and red color. Next one you can see here, student, this is going to give the Cl, student, and this is going to give the NO2. So if they are giving the different ions, student, that is what going to be the ionization isomerism, student. Here you see, student, the difference in which ions is included as a ligands and which is present to valence the overall change. The ligand given in coordination sphere and the anion present outside the coordination sphere are exchanged with each other. Now let us see little bit, we are going to give the detailed description. If you are talking about the PT, student, it is the NH3 how many times, student, that is the 4 times Cl2, and here is the Br2, student, this is the Br2. If you are ionizing, student, it is going to give the complex ion, student, along with what it is going to give, student, bromine ion. So here it is there, student, PT, NH3 how many times, student, 4 times Cl2, student, this is. So it is here is 2 plus 2 Br minus, student. So what ion it is giving, student? Br ion. Same compound if you see, student, same isomerism. If you are taking PT, NH3 how many times, student, that is going to be 4 times. Br is inside, student, and Cl2 is outside. So if you are ionizing in the water, student, so what it is going to give, student, this is PT, student, NH3 how many times, student, that is going to be 4 times Cl2, student, not the Cl2 here, because inside what is there, student, inside here is the bromine. So in spite of the Cl, it is going to be what, student, that is Br. So Br is inside, Br2 is inside, student, here is 2 plus, student, but here is 2 Cl minus. So you see, student, in this case what are the ions are giving here? Bromine and chlorine, chloride ion, bromide ion and chloride ion. So they are differ in the ions produced, student, that is why they are going to be ionization isomerism, student. So once more, if you can, if you want, student, you can understand this one. So student, in the case of ionization isomerism, compound is having same molecular formula, but they are differ in the ions produced in the aqueous solution, student. So they are going to be what, student? Ionization, isomerism, student. There are the three examples are given, student, in this one, that you can understand easily, student. The first one is, student, here you see the first one is there, student. Br2 is there, student, outside, so it will give bromine ion, it will give Cl2 ion. So compound with the same formula but which gives different ion in solution exhibit ionization isomerism. Same molecular formula but give the different ion in the solution. Thank you very much for watching.